Let's understand how the default sort mechanism works in array. When we are dealing with the default sort, it means we are not giving any custom behavior for the sorting operation. Let's see with a couple of examples how this works. Let's say we are having an array of an integer number 3, 1, 2. Let me just console it and confirm on the screen first. Yes, everything is perfect. Now I want to perform a sorting so that these numbers will get sorted and it will be 1, 2, 3 in an ascending order. So if I want to do that, I can say array dot sort. That's perfect. And remember, we are not giving any additional parameter. It means we are using the default behavior for the sorting. Let's see the results now. So it's 1, 2, 3. So the sorting is working very perfectly in this case. Along with this, we also understood when we are performing dot sort here. So the sort method is sorting our original array. It is not creating a new array out of it. So it is sorting an existing array, and that's the reason after this sort, it is not needed to reassign to some other array or maybe the same array. So this is important behavior to understand. Even though if you just hover your cursor here and see the documentation, it returns some value. What is that value? It is the same reference to the existing array itself. It is not anything different. If you want to confirm that, let's say let temp array. Okay. And here what I'll do, I'll perform a comparison between array and the temporary array. Let's see the results now. True. Because this is modifying the same array which is present here, and the temporary array is also referring to the same array. That's the reason. So there is no need to write like this. This will be sufficient. Now let's try to understand the array sort method in detail, how exactly the sorting is happening. So the sorting by default is performing in ascending manner. What if we want in a descending manner? So what we can do, once we are done with the sort, we can say array dot reverse. So now we should be able to see 3, 2, 1. Yes, 3, 2, 1. Okay, that's all good for the integer one. Let's try to do the same operation for string related array. So this is my array of string, which is holding C, after that A, after that B here. And I want to apply the sorting here. Array dot sort. Okay, and console it. Let's see the results. That's perfect. It's giving us A, B, and the C. Now, previously we have given integer. This time we have given string, but it's still working. And how it is able to identify which is the smaller and which is the bigger one? That's the question. To answer this question, what I will do, I'll just change the capital letter A to small letter a here. And let's see what happens now. So surprisingly, for our ascending, the B and the C are coming very perfectly because B is smaller than C, but A is coming at the end. It should come at the start because A is smaller than B and C. And if I again change it to the capital letter A, you can see everything will work perfectly. A, B, C. Only the problem is coming when I'm making A is small. Let's see. So I'll just take a small pause here so that you can try to understand what's the reason behind this. Yes, let's continue. So the reason behind this is if you just hover your cursor on the sort mechanism, it will tell you the function used to determine the order of the element. It is expected to return a negative value if the first argument is less than the second argument. This is all happens when you are giving a custom mechanism for sorting. But what's the default behavior? The sorting will happen based upon the ASCII character order. So right now we are not using the custom behavior. So the default sorting is based on the ASCII character order. So what exactly the ASCII character order? Let's try to search it on the Google. So if you just Google ASCII table, there are a variety of resources you will find regarding this. So ASCII is a character set in which there are around 127 characters. So this is right from the character code start from 0, 1, 2, 3, 4, and again we are 32 something, 64, 65, 96. It is up to 127. And here, if you see the values present for yes. So this is 0, 1, 2, 3, 4, 5. These are the numeric numbers. So what are the ASCII codes for that? Equivalent ASCII values 48, 49. For the number 5, 53. For the number 9, 57. And if you come here more forward and see the ASCII values for capital A, capital B, this is 65, 66. And if you see the equivalent ASCII values for small a, b, these are 97, 98. So based upon these ASCII values, the sorting is getting performed and the ascending order is decided. So as the ASCII value for small a is 97, which is of course bigger than 65, 67. So as per the ASCII ascending order, the A is coming at the end in our case. So what we will do here, we are having A, B, right? We'll try to pick up any character which is below 65 and 67. So we'll try to get this 8 at the rate symbol itself to verify. So what I will do here, instead of this A, I'll try to put at the rate symbol. So at the rate symbol should come first, then B, and then C, because as per the character value here, 64 is the smallest one, then 66 will come up, and 67 for the values here. Let's see. That's perfect. In the similar way, let's also try for something else. We have a curly bracket here, the opening curly bracket. The opening curly bracket value is 123, which is almost the highest that any other small letters or the capital letters. So let's try with opening curly bracket. It should come at the last. Yes, it's coming. So this is how the by default sort mechanism will use the ASCII table and ASCII values to perform the sort in an ascending order.